Hey everybody, we are now near the end of the topic, and what we're going to be doing is trying to combine all the skills you have into one problem. So if you want, take a minute to pause the video to copy down this circuit with the 10 through 60 ohm resistor, and on the right you'll notice that there is a table. It has voltage, current, resistance, and what will be power. That's where the answers go. So that just goes on the side. You'll see in the homework that I kind of gave you a chart to fill in. It's just a good way to organize your answers once you get them. Again, I want to stress that's just where the answers go. Some people look at the chart and trying to figure out what to do. There's nothing to do. You put your answers in the chart once you get them. Now, pause the video if you need to. And if you didn't, I'm still here. So the first goal is to find the total resistance of our circuit. That's our equivalent. You've been doing that. Now, I want to stress some of you are very good at just circling things and writing down fractions and getting an answer without redrawing. If you don't redraw, you will not be successful. This is not a challenge. This is an absolute fact. You must redraw every time you combine resistors. If you don't redraw the circuit, you won't get it. Every year, there are people that think this is the easiest thing in the world, and then there are people like, I just can't get it. Why can't you get it? Because you're not following a procedure because you think you could do it your own way, and you can't. Simply follow the procedure. So let's start, shall we? So the first thing we're going to do is we're going to look for some things that are either in series or parallel. Hopefully you see right away the 20 and the 30 here are in series with each other, and the 50 and the 60 are in parallel with each other. So I'm expecting you to be able to do that on a calculator on the side if you want, by doing like 1 over 50 plus 1 over 16, taking the inverse of that and getting 27.3. But those are the things we're combining, and so I'm going to redraw the circuit. Again, if I haven't stressed it enough, you have to redraw. It's not a challenge. It's a fact. Just redraw the circuit. 10 ohms, 50 ohms. We got our 40 up here, and then we have over here, this is 40, and then this became 27.3. Hopefully you can see immediately after that the only move you can make right now is that the 40 and the 27 are in series. The 50 and the 27 are not in parallel because when the current reaches this junction here, it splits. It doesn't go to the 27 and the 50. It goes to the 40, the 27, and also the 50. So the 50 and the 27 are not in parallel because the current doesn't split into them. So I'll combine those two and I will redraw the circuit. You have to redraw the circuit. Am I making it clear? I think you have to redraw the circuit. So we got the 50 here, and then we have the 67.3 here. 67.3 ohms, 50 ohms, and 10 ohms. So hopefully you see that your next move here is combining the 50 and the 67 in parallel, which you could do on a calculator on the side. 1 over 50 plus 1 over 67.3. Take the inverse of that, and then guess what you're going to do? You're going to redraw the circuit. Am I stressing that enough that you must redraw the circuit? If you don't, you won't be good at this. You'll be getting everything wrong and not know what to do. Seriously, follow the procedure. So that's 10 ohms, and those two in parallel became 28.7 ohms. Hopefully it's pretty obvious that these two together are just in series. So we're going to be combining the 10 and the 28.7 to get down to our last circuit, which is right here at 38.7 ohms. Okay, so that's step one. We got down to the total resistance. I'm just filling in the voltage on each one of these pictures, 100 volts, 100 volts, 100 volts. Your next step, step two, is find how much current is coming out of the source and flowing through this resistor. So current from the source equals voltage of the source over R equivalent. So that's 100 volts over 38.7 ohms, which is, give me a second, 2.58 amps. 2.58 amps. This is a mandatory step. This and drawing the last circuit here Some people skip this step right here that I circled, where you just don't draw the last one. Those people that don't follow procedure don't do well. Just follow the procedure and crush this stuff. So anyway, we now know that there is 2.58 amps flowing through this resistor. We also know, since it's the only resistor, that it's the same as the voltage source, 100 volts. Yippee! Now we get to work backwards on our picture. So please pay attention to the questions I'm asking. Now, when we looked at the previous, when we went from this circuit here to this circuit here, we combined two resistors that were in parallel, in series, oh my goodness, in series, the 10 and the 28.7. You'll hear me ask, what is the same in series? In series, by now, you have to know that the current is the same everywhere. So if these two resistors became this resistor, don't overthink it. Current is the same in series, literally the same. So I'm going to write 2.58 amps next to this one and 2.58 amps next to this one. After you have the current and you have the resistance, you can quickly find the voltage by just doing V equals IR. That's all we're doing, V equals IR. So this will be 25.8 volts, and this one here will be about 74 volts. Now, we're actually done with this resistor. All the values are there. Now that all the values are there, you can fill them in your chart. Not before, just fill them in your chart. So what do we got here? We got the voltage is 25.8 volts, and this is 2.58 amps. Okay, time to keep working backwards on our pictures. So, oh, sorry. Also a side note, you'll notice that the in series, not only is the current the same, but the voltages should add up to the total. And if you add 26 and 74, hey, surprise, surprise, you get 100. So keep that in the back of your mind. All right, working backwards now. We went from this circuit here to this one here. Okay, when we did that, we combined the 50 and the 67 in parallel. Question, what is the same in parallel? You should know by now that it's voltage. And if the 50 and the 67 became the 28, seriously, do not overthink this, and they're in parallel, and you said the voltage is the same, then the voltage is the same. You can write 74 volts, 74 volts. Now that we have the current for each one, the voltage for each one, we can use V equals IR to solve for the current, which I will do. And this becomes 1.1 amp. This becomes 1.48 amps. Side note, in parallel, the voltage is the same, but if you add the currents, you get 2.58, which is the same as it was over here. It's a good way to check your work as you're going. Now, neither of these is an original resistor, so it's time to go backwards to our previous circuit. When we went from this circuit here, our second one, to here, we combine the 40 and the 27 that are in series with each other. Again, the one question you ask, what is the same in series? In series, current is the same. And if these two became the 67, then the current is the same as the 67. So I am going to write right next to this 1.1 amp, 1.1 amp. Now that I know the current for each one, I can find the voltage for each one. So this will be 44 volts. And the one here will be 29.7 volts. Also, little side note, 44 plus 30 equals 74, which is, hey, look, the voltage on the resistor there. Just throwing it out there as a good way to check your work. But the 40 is one of our original resistors. It's done. So I can fill in my chart. That's where the answers go once the resistor is solved for. So the 40 is 44 volts, and this is 1.1 amps. Okay, time to work backwards one last time. So when we went from our first circuit, this big one here, to this one here, our second circuit, we did a little combining. We combined the 50 and the 60 in parallel to become the 27. Again, what is the same in parallel? Voltage. Well, if these two became that one, then the voltage is the same. So this will be 29.7 volts. This will be 29.7 volts. When we went from the first to the second, we combined the 20 and the 30 to become the 50 in series, and in series the current's the same. So if the current on the 50 is 1.48, then the current on the 20 and 30 is 1.48. So I'm going to write that right next to it. 1.48 amps, 1.48 amps. Hey, we now know the resistance and the current, so we can solve for the voltage. So this one will be 29.6 volts. Again, all I'm doing is V equals IR, and this is 44.4 volts. So these two are done. Those are done. And for the 50 and the 60, we know the voltage, so we can quickly solve for the current. Again, using V equals IR. This is 0.6 amps, and this is 0.5 amps. And now those two are done. Yippee! You can take that information and put it in your chart. And then once the chart's filled out, you're basically done. So I'm just going to fill this in really quick. All right, so I paused the video and just filled in the chart. If you need to pause the video to fill in the chart, you can as well. I'm adding one last thing to our chart, the source. So I'm going to put that at the bottom, the source. Sorry, I'm squeezing this in because I have a small screen. Now, source voltage is 100. The source current is 2.58. And the equivalent resistance is 38.7 ohms. Okay, so you'll see that in your homework that there's an area for the source. That's basically all the information you get from this last circuit here. Now, there is a way to check your work. It is not mandatory, but I'm going to show it to you really quick. What you can do is you can solve for the power of the source, which I would suggest using P equals IV. And we'll go a little purple here just for fun. And if I just multiply these two together, I get, I'm talking these two, P equals IV, I get 258 watts. Now, I'm going to solve for the power of each one of the other resistors by doing P equals IV. You want to pause the, I'm going to pause the video actually, and come back when it's all done. All right, I'm back after writing all those down. Now, if you were to take all of these powers and you were to add them up, you actually get 257.2 watts. This is basically the same as the source. That's a good way to check your work. Okay, it's not foolproof, because if for some reason you thought the 20 and 30 were in parallel and you did that, it would still, the power would still come up adding together. Like you took the power of every resistor, it would still be the power of the source. It just means you didn't make a math error. There's a couple other things that we need to discuss. So I am going to pause for a second. Actually, no, I can't. There's a couple other things we need to discuss. Sorry. First thing, you can't have a voltage more than the source. So you might want to like write that down somewhere. Voltage can't be more than source. Can't be more than the source. So you know you did it wrong. If you get like the voltage on the 10 ohm resistor is 120, it's not possible if the source is only 100. Now here's the other way to really check your work. It's really simple. So I'm going to go with a little, I don't know, go this pinky here. If you start at the source and draw a loop and get back to the source. So that's what I just did there. Okay. I passed through the 10, the 20, and the 30. If you take a second and add up the voltage of the 10, the 20, and the 30, I'm doing really rough math here. I think you like these three voltages, if you add them up, you get 99.8. Hey, that's pretty close to 100. That's a good thing. That's what you want to see. So we try again. Let's try going through the 10, the 40, the 50, and then back to the battery. No, you can't go up through the 30 and 20. You're going against the current flow. So now we have 10, 40, 50. All right, let's look that up. We got the 10, the 40, and the 50. So it looks like if you add these together, you could probably get, this is doing mental math, 99.5, which is pretty close to 100. So it's a good way to check your work. So I'm just throwing that out there. I realize that this is only one example, but it's the only example we ever do in class. And then you're allowed to work on your own. So you may want to visit me for office hours on this one, or you may want to schedule a time. If you're really having trouble, I can take you through one. I also want to mention that the homework solutions don't quite look it like this. The issue is I can't just draw it out and then put all the answers on the circuit because you won't see the process. So here's what the solutions look like. So you can see here, this is what the homework solutions are going to look like. The first one I started, the first circuit, I labeled it as A. I collapsed the 20 and the 80, which became 16. That's circuit B. And then circuit C is the last circuit. Now, I can't just work backwards on each of these circuits because you'd never know how I collapsed it down in the first place. So what I had to do then was take, we're supposed to work backwards, but instead I just redrew that circuit over here. And you could see that I filled in the currents and then the voltages. And then instead of going from B back to A, I actually redrew A here for E and filled it in. Again, the reason I'm doing this is if I just gave you 3 pictures, 1, 2, 3, and they had the answers in them, you'd never know the process. So what I had to do was do A, B, C, get down to the equivalent resistance and find the current coming out of the source. And then again, D is just a redraw of B. You don't need to do this. You'll be working backwards on your pictures. But I had to do it for the homework solutions so you could see the process of kind of like working backwards, even though I had to redraw B here and work backwards on it. And A, I redrew over here. I hope that makes sense. If you have any questions, you know where to find me. Take care.